So now we move over to interest rate management. So where does interest rate management come into play? That's because of interest rate risk. Interest rate risk comes from the following. The assets here are usually long-term. They have long maturities, a long duration. Remember, number one, if interest rates go up, bond price goes down. And if the bond is running for a very long time, for 30 years, then it's going down by a lot or little? By a lot, right? So any asset with a long duration is very sensitive to interest rate changes. It's reacting a lot. Assets with short durations are reacting only a little bit. And that is putting the bank at interest rate risks, which is separate from liquidity risk. Let's go straight to an example. Just a reminder, for zero coupon bonds, duration is basically the same thing as the time to maturity. For all other bonds or financial instruments, the durations are slightly shorter than the time to maturity. Remember how we had that big table there? We have your cash flows. If you have all cash flows only at one time, let's say in 10 years' time, you have to wait for 10 years to get money, and the duration is 10 years. So if you get some earlier, let's say some cash flows you get after 5 years, and some other cash flows, the same amount you get after 7 years, then the duration, the average time is in the middle, 6 years. Good. Gray means not important for our class, but quite good that you've seen it once. So the duration formula we had beforehand, this one is saying how much any security or any asset or any liability is changing in value in percentage. So the absolute change over the old price equals to minus the duration times the change in interest rates divided by 1 plus R. So this is basically the formula that we will use now for quite a few things. And we can do that for assets and liabilities. Let's check. Number one thing that is nice about duration is it's so-called additive. That means if you have a duration of 100 different assets, and we mix all these 100 different assets in one portfolio, we don't have to start from scratch, but we can calculate very fast what the duration of the total portfolio will be. And you can imagine a bank's balance sheet simply as a portfolio. On the asset side, it's a portfolio of lots of different loans, of cash, of government bonds, etc. And all of these balance sheet items have a certain duration which the bank knows. And now the bank can calculate the duration of all its assets simply by saying, let's make a simple example. Let's say we have 33% in asset 1, 33% in asset 2, and 33% in asset 3. Then we just have 1/3 of the duration of 1, 1/3 of the duration of 2, and the third of duration of 3. And then we have the duration of the complete asset side. And let that sink for a second. And we can do the same game for all the liabilities as well. Just that we use then all the different liabilities and the percentages. Just add them together, and then we get the duration of the liability side. Now, why is that so interesting? Once we've got the duration of the assets and duration of the liabilities, and we of course know how much assets and liabilities we have, we can do tests. We can see, well, if interest rates change by a certain amount, how much does the value of all our assets change? And how much does the value of all our liabilities change? So what will be the change in the balance sheet in values? And these are not changes because we're buying or selling something. These are changes in the prices or the value of our assets and liabilities. Duration gap. So if the duration of the assets is longer than the duration of the liabilities, so let's say we've got 30-year mortgages on the one side, and we've got 1-year savings on the other side. So then the duration of assets is longer than the duration of liabilities. And now I crank up the interest rates. We know if the interest rates go up, the value of fixed interest rate assets will go down. Just imagine it like bonds. The value goes down. We know that the value of the assets will go down, and the value of the liabilities will go down too. But the value of the assets will go down by more, because we have here times 30, and here just times 1. 30-year duration, my example, 1 times duration. And that means here, if the change, by the way, this would be a negative change in my example, interest rates up, values go down. So assets would lose more than liabilities. Now, is that good for you or bad? If you have a certain amount of assets, and you also owe other people money, and the value of your investment is going down by more than how much you owe other people. That's going down a little bit too in present value terms, but not by as much. Bad. And it's also bad for banks. This financial institution would be afraid of interest rate rises. Interest rate falls would be good for that bank. And you can see that in a practical example too. So this is how a typical bank looks like. Duration of the asset side long, duration of the liability side short. I'm just making it a little bit more practical. I just want to see a balance sheet. Just imagine here 30-year mortgages, 1-year savings accounts. If the interest rates go up in the market, in the Australian economy, and I've got 30-year mortgages, fixed interest rates, can I change these interest rates? No, they're written down in the contract. So the duration calculation already takes care of it if it's fixed or variable. Good. So these interest rates are fixed. What's happening with the short-term interest rates here, with the 1-year savings? They can't go up immediately, but after 1 year, the customers, will they be happy with the old interest rate if the whole interest rates in Australia went up? Or will they say, we want higher interest rates too? Well, the customer wants to have higher interest rates too, right? If they can earn more money at other banks in the financial markets, they say to this bank, I want higher interest rates too. Now, of course, we as customers don't have much power, you might think. But if you can earn more interest somewhere else than at your bank, you can't force your bank to pay you more. But what can you simply do? Withdraw money. So the banks, in that sense, have to be competitive and have to offer you enough return. So that's an alternative explanation why typical banks are worried about interest rate rises. But let's go back to using our duration here. So we've got here the formula how our assets are changing. Here we've got the formula how the liabilities are changing. Now, bank equity is the worth of the bank, the net worth of the bank, and we want to maximize that. We want our bank to be as valuable as possible, right? Now, bank equity we are calculating by subtracting the value of the assets minus the value of the liabilities. So therefore, bank equity changes if the change in assets is, well, it depends upon, basically the change in assets minus the change in liabilities. Depends upon if you're going up or down which direction, right? But if the change in assets is more than the change in liabilities, and let's say if you're going downwards, like in my example beforehand, then equity would be negatively affected. Right? Since we've got a formula for the change in asset and we've got a formula in change in liabilities, we can also calculate the change in equity. So what I do here is instead of delta A, delta by the way just simply stands for change, I write down the formula from beforehand, this one, minus dA times A times and so on. So that's the one in the first brackets. And instead of delta L, I'm also writing down the formula for delta L. Then in the next step, I can just pull out the delta R divided by 1 plus R outside of the brackets. What else can I do? I can also pull out the A. Well, if I do that, I've got here at this spot L divided by assets, L divided by A. And I just define L divided by A simply by K. And then I end up with this formula. So these two formulas are identical. It's just an easier way to write it down. Right? Now, this formula is important because this is a simple formula. Once we've got the duration of assets, duration of liabilities, we know the leverage of the financial institution. We know how big the financial institution is. And now we can easily estimate how much equity will change for given changes of interest rates. So this is going to be an important formula for us. And not only for us. So actually in the real world, APRA, so the Australian banking regulatory authority, and banks themselves, they use these formulas too to evaluate how much risk, interest rate risk they've got on their books. So these are the different sets in there. I actually want to get quicker to an example. This is in words, right? So the change in equity is the negative adjusted duration gap. Adjusted duration gap is this thing here. Just think of it as a duration gap. Times the size of the bank, times the size of the interest rate shock. And here's a practical example. Typical bank, lots of different assets, 100. And we say the duration of all these assets, we've calculated that beforehand, is 5 years. And then we've got liabilities, 90. And we say the duration of these is 3 years. So we've got a typical bank, long on the asset side, short durations on the liability side. So they do maturity transformation. And the current interest rate is 10%. Let's call that interest rate level. Let's just keep it life simple and say it's 10% on both sides. Same thing. Unrealistic, but simple. And we are afraid that the interest rate might go up to 11%. And now we want to use that formula to see what would happen to bank equity, to our profitability, if interest rates are rising. So first thing, before you even use the formula, I think it's very useful to just think about. If the assets are very long and the liabilities are short, rising interest rates, good or bad for you? If you've locked in the interest rates on your asset portfolio, fixed for 5 years, but the interest rates on your debt, on your liabilities, is adjusting after 3 years, and interest rates go up now, is that good or bad for you? It must be bad. So it doesn't matter what the formula is telling us, for sure it must be bad for the bank. And I would always suggest, as soon as you've got some calculation in the exam, always make the logic check first, so that you don't calculate a positive number in this example here, and then you're surprised that it's wrong later on, that you don't get the points. So do the intuitive check first, so we know it must be bad for the bank. They must lose equity value here. Now we just plonk in the numbers. Duration of our assets, 5 years. Duration of our liabilities, 3 years. Now little k is a little bit harder. Little k was L divided by A, which is basically showing us a little bit of the leverage. So it's 90 divided by 100, 0.9. Times assets, 100. Times the change in the interest rates. So it's going up by 0.01. By the way, here, hint, you can write 1%, but it's much safer if you write 0.01. Because with the calculation, the chance that you get the correct result is much better if you use decimals. Same thing here. So R, the old interest rate was 10%, meaning 0.1 plus 1 is 1.1. And now we plonk all these numbers into the calculator. Don't forget the minus here. And we get minus 2.09 million. So equity will decrease by 2.09 million. Now what does that mean? Basically it means if interest rates really go up, you can imagine the balance sheet, the worth of all your mortgages, we can calculate the present value of these things. Or imagine it as bonds, and we can calculate the present value of the bonds. So if interest rates go up, the present value goes down. So our asset side is going down already. But same thing here, you can imagine the liabilities, we can calculate the present value of all of our liabilities. If interest rates go up, their present value goes down too, but by a different amount to the assets due to a different duration. And now this formula takes everything into account, and it turns out that asset present values decrease by more than liability present values. And since equity is assets minus liabilities, it turns out that we also lose some equity. So that's bad for the bank. So on paper, you can imagine they made a loss by changing values of assets and liabilities of 2.09 million. Good. Let's do the same game here now, decreasing interest rates. So we've got exactly the same bank as beforehand, but now it is decreasing from 10% to 9%. Assets long, liabilities short. if interest rates go down, the value of assets and liabilities will go up, the present value. Which one goes up by more, the assets or liabilities? Look at the durations. Assets. So if assets increase in value more than our liabilities, we are happy or unhappy? If your investment, all the money that you've invested somewhere, is gaining more in value than the debt that you owe to your friends, unhappy or happy? Happy. Same thing here for the banks. So the bank will be happy in the sense that their equity value will go up. We know that already. But the question is by how much? And if you understand the formula, you can say it like this. If not, it's a fantastic chance now to type in the numbers into the calculator and see if you're able to use that formula. We want to calculate the change in equity, duration assets 5 years. Duration liability, 3 years. K is defined as L over A, 0.9, times A, 100, times the change in interest rates. And now here we have to watch out. The interest rate is decreasing from 10% to 9%. So the number, that's a really tricky one here. It's going down from 10 to 9 minus 1%, but I don't like you to write down percent here, so instead of saying percent, you can write down minus 0.01. Be careful with the zeros, right? Very easy to put in an error there. And then basically it looks exactly the same as here, just that there's a minus sign here now. Which means the result will also be the same, just that instead of a minus, you will have now a plus, just as we said before, and the bank will be happy about the situation. So the value of equity will go up by 2.09 million. So it's symmetric in both directions. Test question, if I would have doubled the change in interest rate here. So instead of going up by 1%, I would have gone up by 2%. What would have happened to this number? So we know the bank is unhappy about rising interest rates. If I rise the interest rate instead of 1% by 2%, even more unhappy, simply twice as much. So that's the reason why I like these formulas here so much. They might look a bit difficult, but imagine how hard it would be to evaluate for each single mortgage to calculate the present value. For each savings account, calculate the present value. For each deposit account, calculate the present value. For all all bank bonds that they have issued, calculating the present value. For all kinds of different interest rates, and then compare them. You would calculate for days. With the duration, much, much, much quicker. Just know the average duration for the assets, liabilities, plonk it into the formula, and you already got a very good approximation of what's going to happen. So that's the reason why we're interested in these. And that's the reason, by the way, why in week 1 I was torturing you so much about the duration, because we need it for this. Good. So this one is another tricky one. So we know already this bank has interest rate risk. So if interest rates go up, this bank is suffering. If interest rates go down, this bank is happy. But altogether, it's uncertainty. It's risk. And nobody likes risks. We want to stay safe. Staying safe means we don't want to have big changes in equity. And the question is, how can we get less changes in equity? We can do something with our balance sheet. Just as we had liquidity management beforehand, and we can have more or less cash, we can also adjust our balance sheet here to minimize this risk. And one way to adjust it is basically with all these variables in here, right? So we can't really adjust much with the interest rates. They're coming from the market. But we can adjust the duration of our assets. We can choose, for example, to invest in shorter duration assets. Instead of buying 10-year bonds, we could buy 5-year bonds, and our duration would go down. Or alternatively, because we are having a too short duration of the liability side, so the difference here is a problem, we could increase or lengthening duration of our liabilities, and banks often do that. Sometimes you see that you get an advertisement letter for the bank, and the bank doesn't say, have more money on your deposit account. But usually what the bank says, we have a new savings account. Put your money on the savings account, and savings account have longer durations. You can't get your money out that quickly. Or put your money on a term deposit account. for 3 months, for 6 months. And that is lengthening the duration of the liability side, and therefore here the difference gets smaller. And once the difference in the bracket gets smaller, the risk of our equity change is getting smaller.